let's look at a little more formal definition for increasing and decreasing functions. So one way, if we have a function y equals f of x, and we're looking at an interval from a to b, so as you go from x equals a to x equals b, the values of y increase, which is kind of what we already talked about previously. And then from if the function is decreasing, we would say that those values of y are also decreasing or getting smaller. Right? So when it's increasing, our y values are getting bigger or growing. And when it's decreasing, our y values are getting smaller. When we look at a graph, the way that we tell that it is increasing or decreasing, we always read our graphs from left to right. And so as you go from left to right, if the function is rising or going uphill, then we would say that it's increasing on that interval. And if we look from left to right, such as here, we would say that the function is going downhill or it falls when it's decreasing. Now, if a function is increasing, like it is on this interval, over that interval, the average rate of change is going to be positive. And if you're looking at an interval where the function is decreasing, then your average rate of change is going to be negative. All right, so let's try this out. On number 14, okay, we have a cubic looking function there. We're looking for the intervals where it's increasing and where it's decreasing. So if I start on the left, and as I look at the function, I'm following it, I see it is going uphill at first. As values of y are getting bigger until right about here. And so that looks like, oh goodness, I don't know, maybe negative 2.5. So I would say it was increasing. And with this arrow here, remember in the previous picture we had a dot, so there was a finite point that it stopped at. If there's an arrow, it actually means it's going to negative infinity. And here it looks like it's going to positive infinity. So I would say it's increasing from negative infinity to negative 2.5. Okay, and then from negative 2.5, if I keep reading from left to right, I see that it starts going downhill until right about here. Okay, so I'd say it was decreasing from negative 2.5 to 0. This is where x is equal to 0. And then after x is equal to 0, it looks like the function is going uphill again. So from 0, and then this has an arrow on it, so it'll go to positive infinity. And so we have two intervals where this function is increasing and one where it's decreasing. Now let's look at how that relates to the average rate of change. So on the interval from negative 8 to negative 3, so that would be somewhere over here, all the way up to about here. So on this interval, okay, is that average rate of change going to be positive or negative? We know that on that interval, our function is increasing. And if it's increasing, our average rate of change will be positive. So we'll circle that positive. Next, it asks on the interval from negative 2 to 0. So that's going to be from about here to here. So that's kind of this section here. We see that it's going downhill, and any sort of line that I draw connecting any 2 points here is also going to go downhill. So my average rate of change on that interval is going to be negative. And then our last interval goes from negative 3, so it starts here, and it goes all the way over to positive 5. So it's got some downhill sections, and it's got some uphill sections, both. So that means the average rate of change could be either positive or negative since it has both uphill and downhill on that interval. So we'll circle the both there. All right, so we have one more function here, and I'd like you to pause the video and see if you can give this one a try. So as I look at this one, and I'm trying to identify those intervals increasing and decreasing, if I start on the left and I go to the right, I see my function is slowly going uphill, then really steeply uphill, and then it kind of slows down again. So it's always moving up. That y value is always increasing. So we would say it's increasing from negative infinity to positive infinity. You could write that with inequalities like this. Or you could also say that it's all real numbers. So if you put two bars on kind of the back edge of that R, that's the symbol for all real numbers. They're all numbers between negative infinity and positive infinity. And since it's increasing everywhere, it's not decreasing. And that means on this interval from -5 to 4, since it's definitely increasing on that interval, our average rate of change will be positive. This question, is there an interval where the average rate of change will be negative? Well, in order to have a negative rate of change, we have to have some place where this function is decreasing. And since we don't have that, we will not be able to get a negative average rate of change.